Okay, hello everyone. I'm Tom. Thanks for joining this session. I think you might have seen the recent announcement of Data Lake UniForm. Data Lake UniForm is a trend topic in the open table formats world. Today, I'm going to talk about Data Lake UniForm and its internal mechanism and what you can achieve with Data Lake UniForm. Before moving on to the content, let me introduce myself. I'm Tomohiro, a senior cloud support engineer at AWS. I mainly work for customers who build data lake with open table formats. I'm an Apache Iceberg contributor. I recently worked for test migration and adding some features. And I also a co-author of AWS Globebook. Okay, let's move on to the content. So initially, I talk about open table format and its challenges. Then I'll explain Data Lake UniForm and its underfoot. Lastly, I'll show you how Data Lake UniForm solves the open table format challenges through a demo. Okay, let's begin with what the open table format is. So these days, open table formats such as Data Lake, Iceberg, and Hudi are widely used many customers for their new capabilities to handle more complex data foundation needs. Open table format is an abstraction layer that provides ACID transaction and also new features such as time travel, upsert, and data compaction into the data lakes. By new capabilities of open table formats, the many organizations and many companies started using the open table formats. However, as open table formats become more widely used, two challenges comes up. The first one is managing multiple open table format environments. If your team is based on Data Lake, if another team queries your Data Lake environment, they need to prepare for the Data Lake client. And the second one is access limitations by client specifications. If your analytic engine only supports Apache Hudi, you need to prepare for the other clients to access it, like Data Lake and Iceberg. So to solve these open table format challenges, and also more widely flexible use, and also beyond service limitations, you need a unified interface to provide these new capabilities. So how can we solve the open table format challenges? I think, as you already know, Data Lake provides a solution, which is called Data Lake UniForm. Let's see the Data Lake UniForm. Data Lake UniForm is a Data Lake feature that provides a Data Lake table access from Iceberg or Hudi client. To use UniForm, if you don't have any Data Lake table on your environment, you create a new Data Lake table with UniForm. Or if you already have Data Lake table, you can just enable UniForm on your existing Data Lake table. And both Data Lake on Databricks runtime and open source Data Lake support this feature. So the UniForm can be widely used on your various environments, like Databricks runtime, AWS, or other cloud environments. So to use UniForm, you need to follow the two steps. The first one is you select a catalog where you register Data Lake table with UniForm. So if you already use Databricks runtime, I think you can use the Databricks Unity catalog. After that, based on your environment, you just create a Data Lake table with UniForm, or you just enable UniForm on your existing Data Lake table. Let's look at each step in detail. At the first step, you choose a catalog for Data Lake UniForm table. These are catalog options that you can use. So you choose the catalog options suited to your analytics environment, like Databricks Unity Catalog or High Meta Store. And if you use AWS, you can choose AWS Guru Data Catalog. And this table outlines the specific conditions for using UniForm. Note that for Hudi, you need to use open source Data Lake 3.2.0. After choosing catalog, you just create a UniForm. So by these queries, you can create a uniform table. And also you can set the both options by adding the table parameters to this query. You may also want to use existing data lake table. In this case, you just run these queries. They are different query between Iceberg and Hudi. So for Iceberg, you just run the real query. And for Hudi, you just run the alter table query. So that's how to use UniForm in your data analytics environment. To see how UniForm works, let's walk through a demo. So as a scenario, there is a data engineering team and its data analytics environment on top of Databricks runtime. The team needs to provide a data lake uniform table that other teams can query for their analysis. To provide a uniform table, they create a new data lake table along with the loading data by create table as select query. Let me show you this scenario through a demo. So this is a view of Databricks notebook that runs Apache Spark. First, you choose a catalog for your data lake uniform table. Okay, then create a Spark data frame to load the data into the data lake table. This table shows the product records you will load. Okay, then create a data lake table, uniform table with Iceberg parameters, along with loading the data frame data. Okay, now it's complete. Let's review the uniform table metadata. So this table output shows the table schemas, and this metadata location is Iceberg table metadata location. And also then the location has a data lake table metadata location and also table properties for uniform Iceberg. Okay, next, let's look at the data lake table location in Amazon S3. So this is a table location in Amazon S3. Let's look at the inside of the table. Here's the data lake uniform table structure. And the first data file is Parquet with Z standard compression. Okay, then data log has a data lake table metadata, such as data file location. Then this metadata has the Iceberg table metadata that has three kinds of files, metadata JSON and two other files. These files point to the same data files like data lake also points to. Okay, so this is the first scenario. Go to next one. In the first scenario, you created the data lake table with uniform for Iceberg. Next, the data analytics team queries a data lake table from their AWS environment. They use AWS Glue that provides Apache Spark runtime. They also use Apache Iceberg in their environment. They can query the data lake table using their existing Iceberg and Spark environment without adding a new data lake client. So let's query the data lake table from the Iceberg client on AWS Glue. So this is the AWS Glue console. Choose each your job in the left pane. Okay, then choose a Glue job to open Glue Studio Notebook. First, you set up a Spark session with the Iceberg configuration. This configuration doesn't have any data lake configuration. Your workspace endpoint and a token are necessary to access the Databricks Unity catalog. Once the Spark session is initiated, let's read the data from the UniForm table. Okay, now it's successful to read the Delta Lake data from the Iceberg client. Run more practical query to get insights from the data. Okay, now your team is able to query to Delta Lake table from the Iceberg or in the AWS Glue. That's how UniForm enables you to query the Delta Lake tables. Let's go back to the slide. So you learned about UniForm and its usage so far. The previous demo showed how to use your UniForm and also how to query your UniForm table from Iceberg client. So in this section, I'll talk about UniForm under the hood and more details about UniForm. As you saw, UniForm provides read access to Delta Lake table from Iceberg and Hudi clients. For write, only data client can write the Delta Lake client can write the data into the Delta Lake UniForm table. When you update the UniForm table, Delta Lake generates multiple format metadata. For writing data, Delta Lake doesn't duplicate records for different table formats. So each format's metadata points to the same data. This is the overview of UniForm mechanism. Next, let me show you more details of how UniForm generates multiple metadata. To show the details of UniForm, let me focus on Delta Lake and Iceberg. You create a Delta Lake table with UniForm like this query. Then Delta Lake generates two table format metadata like this. The left one is Delta Lake metadata, and the right one is Iceberg table metadata. After creating a UniForm enabled table, let's write records by inserting to query. So running an insert into query writes the data files in your storage in a selectable format. Here, Parquet with this standard compression. Then, Delta Lake and Iceberg metadata generated, so both pointing to the same data files. So Delta Lake with UniForm doesn't duplicate data files. Instead, it creates multiple metadata for open table formats. When you read from the table, Delta Lake or Iceberg client, so initially checks the relevant metadata, then reads the data. So this is how Delta Lake UniForm allows different clients to read Delta Lake table data. You saw how Delta Lake UniForm works for open table format challenges so far. So now let's look at the real-world use case, showing how UniForm enables access to Delta Lake tables for clients that cannot access the Delta Lake tables. An example use case for Delta Lake UniForm is Amazon Redshift. Before moving on to the demo, let me briefly introduce Amazon Redshift. So customers build their analytics environment on AWS, and they use Amazon Redshift for large analytics workloads as a cloud-based warehouse. You can use Amazon Redshift to query your data in Amazon S3 using Amazon Redshift Spectrum. You can also query open table formats tables by Redshift. Currently, when you query Delta Lake tables from Amazon Redshift, you can read a table from Delta Lake manifest files. So the manifest file is a set of the list of data files. To read a Delta Lake table from Redshift, you need to generate a manifest file by a generate query. So, and to reflect the latest status of Delta Lake table, you need to create a manifest file every time the table is updated. So let me show the operational flow of generating Delta Lake manifest files. First, you run a generate query on your Delta Lake table to create a manifest file. After this, you can read the Delta Lake table from the Redshift. You can automate this generation with Delta Lake table configuration. However, after each update to data lake table, you need to create a manifest file for Redshift to read the table. But if you enable UniForm, your existing data lake table, you don't need to create manifest files for Redshift because you can directly read the data lake table as an Iceberg table from Redshift. So this is about what UniForm tries to solve. Next, I'll show you a demo how UniForm provides a data lake table access from Redshift. Let's say data analytics environments uses data lake on AWS. Your team runs read and write queries on the data lake table using Amazon EMR cluster. One day, the data analyst team requests your data lake table using Redshift for their analysis. To share the data, you enable UniForm on data lake table from Amazon EMR. Then the analyst team can query the data lake UniForm table from Redshift. Let me show you a scenario. First, let's look at Amazon EMR to enable UniForm. So this is a Jupyter notebook connecting to Amazon EMR. The first cell is set parameters to use data lake UniForm on your EMR cluster. After setting the parameter to EMR, initialize Spark session. Like the previous demo, data lake and Iceberg parameters are set to the Spark session. Okay, let's review the current table metadata before enabling UniForm. The table shows the data lake table metadata, like table schema and a location and the properties. Okay, so next, review the current table records by select query. The table has customer reviews for their orders, like drink and also review and star rating. Okay, now run real query to enable UniForm on this data lake table. Once it's complete, review the table metadata again. The metadata was changed after running the real query. The parameters of UniForm for Iceberg were added into the table properties. Now we enabled on your existing data lake table. Next, open the Redshift console and query this data lake UniForm table. So this is the view Redshift query editor. Now you run two queries, like the basic one and a more practical one. Run the first query. It's a simple select query. The query returns and shows the table data on the editor. Now you can read the records in the data lake table from Redshift. Let's run more practical query to get insights from the table data. The query returns the data. You can also visualize your query results on Redshift query editor like this. Previously, you enabled UniForm on the existing data lake table and queried the UniForm table from Redshift without creating any manifest files. Next, return to the EMR notebook and write new data to the UniForm table. Then query the table again from the Redshift to review the added data. Write new records into the data lake UniForm table by data lake client on Amazon EMR. Before writing records, check the new records. So new records have a new category like industrial supplies category. So after review this data set, write the record by insert query. Okay, now it's complete. So go back to the Redshift editor and check the table records again. So let's run the same analytic query on the data lake UniForm table. Now the output shows the records with new category industrial supplies. Now we confirm writing new records reflected on the read query results. So let's compare between the first and the second query results visualized on Redshift query editor. The query result on the right side reflects a new record industrial supplies like this. So that's how Data Lake Uniform works for clients which has limited access to Data Lake like Redshift clients. So to summarize the session, so Data Lake Uniform allows Iceberg and Hudi clients to access Data Lake table. It creates multiple table format metadata from a single data copy, and enable Uniform lets Iceberg and Hudi clients access Data Lake table, even though there's their specifications. Okay, that's all from about Data Lake Uniform today. Thanks for joining this session. Thanks very much.